My name is Sai Tejas Naidu, and my teammates are Srinivas Rohit and Singotu Balaj. We are from RMD Engineering College. Our project is based on multiple disease prediction using machine learning. Our guide for this project is Professor Mrs. M. Shakunthala, Assistant Professor of Department ECE, RMD Engineering College. The objective of the project is to make a system that will help the end users to predict diseases on the basis of symptoms given without visiting the hospitals. The main objective of this project is to decrease the OPDs of the hospitals and bring down the workload of the medical staff and reduce the costly treatment and the panic moment of the end stages. With a proper medication can be provided at the right time, and we can lower down the death rate as well. To analyze accuracy by using machine learning algorithms, altogether this system will be help in easier health management. The abstract of this project is to identify the disease prediction using machine learning. The based on the model that predicts the disease of the patients according to their symptoms provided by the user as the input to the system. The first task is to determine the problem statement. After that, we can computerize our data using scatter plot, distribution graph, etc. By doing so, we can find out anomalous missing values, etc. on our data and make our dataset perfect for prediction. We use logistic rejection model, which is very useful in binary classification. Our main goal is to make patients comfortable in using single model instead of using different predicting models for different diseases. This may consume more time for prediction or patient has to wait until the system loads. Existing methods of the project. Mainly the existing machine learning models for healthcare analysis are concentrating on one disease per analysis. For example, first is for liver analysis and one for cancer analysis and for lung analysis like that, so on. If a user wants to predict more than one disease, he or she has to go to different websites. There is no common system where one analysis can perform more than one disease prediction. Some of the models have lower accuracy, which can seriously affect patients' health. When an organization wants to analyze their patients' health reports, they have to deploy many models, which in turn increases the cost as well as time. Some of the existing systems proposed method in multiple disease prediction, it is possible to predict more than one disease at a time. So the end user does not need to traverse different sites in order to predict the diseases. We are taking three diseases that are liver, diabetes, and heart, as all the three diseases are correlated to each other to implement multiple disease analysis. When the user is accessing this API, the user has to send the parameters of the disease along with the disease name. Our project will invoke the corresponding model and return the status of the patient.
When it comes to requirement analysis, Python is a popular programming language in the field of machine learning. Due to its simplicity and versatility and extensive libraries, another advantage of using Python is multiple disease detection is the ability to integrate different ML techniques such as classification, clustering, and regression. These techniques can be used to identify group of patients with similar diseases, predict disease progression, and provide personalized treatment recommendation. Platform for the that provides a free environment for developers and data scientists to write, run, and share code. It is based on the Jupyter notebook and allows user to work with the various programming languages, including Python, R, and Scala. Anaconda Navigator is a desktop graphical user interface, including an Anaconda distribution that allows you to launch application and easily manage Anaconda packages, environment, and channel without using command line commands. Anaconda distribution is of the Python and R programming languages for scientific computing regression. Logistic regression is a commonly used machine learning algorithm for disease prediction. It is a statistical method that model probability of a binary outcome, such as the presence of options of a disease based on one or more predict variables. In disease prediction, logistic regression can be used to identify the risk factors that are associated with a particular disease and to predict the likelihood of individual developing the disease based on the personal characteristics. To apply the logistic regression to disease prediction, a dataset is typically collected and that includes information about patients, including demographic, clinical, and laboratory data. The data set is then split into training set and a test set. With the training set, we use to train the logistic regression model, and the test set we use to evaluate the performance. When it comes, the logistic regression model learns the relationship between the predicted variables and outcome variables. When it comes to support vector machine is another commonly used machine learning algorithm for disease prediction that can be used for predict the risk multiple diseases simultaneously. SVM is a binary classification algorithm that uses a kernel function to map input data into highly dimensional feature space, where the classes can be separated by hyperplane. The SVM model learned to classify patients into different disease categories based on their individual characteristics such as age, gender, and medical history. The SVM analog algorithm finds the optimal hyperplan that separates the different diseases categories in the high dimensional feature space, maximizing the margin between the classes. One of the advantages of using SVM for multiple disease prediction is that it can handle high dimensions data and it is relatively insensitive to the number of features. Additionally, SVM can handle both linear and non-linear relationship between the variables and disease outcomes. This makes SVM a versatile tool for disease prediction and
for Parkinson disease detection, which is used to detect the Parkinson disease. And this is the code for diabetes detection, which is used to detect the diabetes. It is the code for heart disease detection, which is used to detect the heart disease. And these are the dataset collection and the testing datasets which we are getting, whether it is a heart disease or not a heart disease. We are getting these results by doing the running the codes, and after that we are opening the Anaconda Navigator, which is a graphical user interface for creating the window, which we are getting the output results. Yeah. Then this is the Anaconda Navigator platform, and in that we can see that environments. In that we have machine learning option. Then coming to the home page, we are getting the machine learning option to get the total local packages, to load the local packages. After completion of all the loading of local packages, then we have to come back to the home page. In that we need to launch the Spider compiler to run our codes. After launching of Spider compiler, we will get all our codes, which differently in we separated in Google collaborations. In this we get all the codes in a same compiler. Then we will run the code. Then we get the loaded package of all the codes. We need to open our file browser, and in that we need to open our streamline command. Streamline command which is used to run the Python scripts. In that streamlit command we get the link for all our codes. After that we need to copy the link and going to Anaconda Navigator and open the terminal, which is in machine learning. In that we need to paste our streamlit run command. After running that, we will get an out local host. By local host getting the local host, we are getting this pop-up of our user interface. We need to enter the values of different disease detections. First, diabetes. In this diabetes, entering the number of pregnancies and entering the glucose level and all, we are getting the exact what the patient will be. In this, we are entering all pregnancies, age of the person, how many BMI value and all. By this we are getting that person is a diabetic. Changing some values, then we can obtain other result. Going to heart prediction using ML and Parkinson disease prediction. In this we are having so many values. After giving these values, we get that result whether the person is having Parkinson disease or not by using machine learning. It is a starting stage of our